Hello everyone, I hope you all are doing amazing. Welcome to my channel Best Math. In this video, we will start with the part 2, the writing part for the end of term 3 exam, and this is for the grade 12 advance. We start with the question 16. It is to compute the area of a region using definite integration. Definite integration means integrals with limits. You will have a and b limits, lower and upper limit with y as a variable of x. Now this is very important, y as a variable. When this means y as a variable, that means this changes or we are deriving with respect to y or the function of y. We will look into the details and we will understand it better. Now area between the curves, the formula is given over here like this. But y as the variable makes a lot of difference because we come to know here there must be dy only. It can't be dx, integral with respect to x. No, because they told y as a variable. This means, now let me just write an equation. Let me just make this clear. So y is equal to say 2x squared plus 3. Here this is an equation, right? Here you can see x is given. Now this is a function of x. Y is equal to f of x, where x is changing. Okay, so now simple equation, another one with respect to x. That means f of x is 2x. Now, how would you find the value of y? It is by inputting the value of x, right? Imagine x is equal to 10. So it will be 2 times 10, 20. That is the y. So x is variable, y is dependent variable from x value. In the sense, whatever y value is dependent on x. That's what it means. Now, if I write terms like this, x is equal to 3y. Now here, y is the independent variable. You can have any values of y. Say, imagine we'll start with 10 again. So x is equal to 3 times 10. Y is 10, that means 30. Now this is dependent on y. Now this is how we must write our equations and use it in the formula. Why? Because we have dy over here. So all these, over here the functions must be with respect to y. In the sense it should be like y squared plus 2y or y minus 3, something like this. We can't write x squared or anything. It must be in these terms. So this is already told. So no matter what the values are given, you can easily get this form. And you should also remember the limits are there, right? Here it's written as CD. You can write it as AB. It's fine. But it's along the y-axis, this y-axis. Why? Because it's with respect to y, right? That's it. So now what basically it means is you want to find this area, isn't it? So what you're doing is you're cutting this, the cross sections. So when your y is equal to x plus 3, just for an example, this function gives you the x values, okay? You're cutting this into lots of subsections, and integration means what? You're adding them all up till way to where? It goes till infinity, but we want only till year to year. So say C to D. So that is how we find the area. That is area between the curves. That's the formula. Now we will see a problem and you'll understand how easy it is. Here, this is the question. This is it you're going to get. Nothing else. Now you do not need to draw accurate graphs. Just basic graphs are enough. Now first thing, find the area bounded by the graphs y is equal to x squared, y is equal to 2 minus x, and y is equal to 0. What I personally prefer is the equations be like this itself. Though we are doing it as function of y, later on we will change it. But for now, let's leave them like this. Why? Because it helps you in calculations. I will show you now. Sorry, graphing. Main thing is graphing. This helps a lot in graphing. Say for example, this is basically square root y is equal to x. Okay? X is equal to square root y. Is this easier to graph or y is equal to x squared? Which is easier to graph? I would choose this all the time if I have to compare with this one. So that is why it's better to get these equations. Even if there are not like this, you can convert like this, graph it, and then use such equations in the formula to solve it out. The step 1 to solve this problem is graphing. You do not need to graph it accurately, just basic graphing is enough. Let me take x and y coordinate, x over here and y. Y is the vertical coordinate, x is the horizontal. Y equals x squared. What exactly is this? It's a parabola. So, it's not accurate. It should touch the 0. So this is a basic graph of parabola. This is y equals x squared. And then we have y is equal to 2 minus x. This is equivalent to minus x plus 2. Why I have written like this is in the slope intercept form. You can see x is having negative sign. That means it's a downward slope. But this plus 2 is the intercept. Plus 2 is the y-intercept. Whichever number is next to the slope is the intercept. That means it cuts along y-axis at that point. And since it's just minus x, it'll be a straight line. It'll be a 45-degree line passing through 2 here. And y equals 0. Now here, before I graph this, students tend to get confused over here. What they think is, okay, it's y is equal to 0, so I will draw a straight line. But no, that is x equals 0. What I personally use is, instead of directly writing y equals 0, I just assume y is equal to, say, 3. What does this mean? Where y is 3, I have to draw a straight line and on the y-axis, because all the y values must be 3. So all y values must be 3 means that's the line. So that is what I do. So you can just remember that for your easy understanding. But now y is equal to 0 means y is 0 over here. This is 1, 2. So I have to draw a straight line at y is 0. So now you can see there's an enclosed boundary. There's a boundary enclosed and the area within that. So this is the area, right? That is what I need to solve for. I need to find that area. So let's write the curves. One is this graph. That is what? X squared. So another one is over here. This downward slope. That is minus x plus 2, or you can write 2 minus x. And lastly, what do we have is this one, y is equal to 0. Now here, what do we need? The formula. Let's write the formula in brief. That is limits. I'm just writing a to b, that is vertical limits. Right function, right minus right of y, okay, with respect to y we are dealing, minus left with respect to y. This is the function dy. This formula does not change. Just write this. You can write your own formula, but this is always the same one. Now here in this formula, how exactly would you write? Would you just write this 2 minus x? No, we need to rearrange it and write it. Okay, we will come to that in a minute. But before that, let's look into the limits. What is the limit? Or what are the limits? There are two limits. So it's along the y-axis, it's dy. So it's from here to wherever this point. But I'm not sure where that point exactly is. It looks like 1, but is it exactly sure? No, how do we do that is, we need to see which are the two equations that touch over here. That's x squared and 2 minus x, right? Y is equal to x squared and y is equal to 2 minus x. Now if I equate it like x squared is equal to 2 minus x, make y equal y and solve it, you will get the touching point, but you will get the x value. See, if you solve this x values you get, right, you will get where it touches along the x-axis. But that is not what we want. We want where it touches along the y-axis, isn't it? So what you need to do is, these equations are there, right? Rearrange them with respect to y. That means you should have x at one side and y over here at the right side. So what do I need to do is, I'll just rearrange them. X squared is equal to y. Here I'll bring this x, minus becomes plus, x is equal to 2 minus y. But here I need to take square root on both the sides. So that square root cancels, it's x is equal to root y. And x is equal to 2 minus y. So now when I equate these both, I'm going to get the y value of it. See, what I need to do is, I just have to equate x is equal to x, that is root y is equal to 2 minus y. Now when you solve it up, you get all the y values where it intersects. Now, obviously, if you look at this, this goes on further. It touches somewhere else also. It intersects again somewhere up. But we need only this value. Okay. So what you can do is you can square on both the sides and solve it up, or directly put this in the calculator as well. It's fine. But what I would highly suggest you is, because this method, whichever I'm going to tell, can be used any other problem. So I would tell you the squaring part. Let's write over here the same thing. Square root y is equal to 2 minus y, right? Since I know they're going to touch at 2 points, I'll have two y values. I'll square them. It'll be y, square on both the sides. Y is equal to, over here when you square, what's going to happen? It's going to be a squared minus 2ab and plus b squared. That is a minus b the whole square formula. Whatever is the first term, square it up, minus 2 times these two terms, 2 times 2 and y, plus the second term square. And then y is equal to, over here it's 4 minus 4y plus y squared. Now take everything to one side. I'll bring this y to the other side and write it. 0 is equal to y squared. This becomes minus, and again minus y, it will be minus 4 minus y, it will be plus 5, sorry, minus 5y, minus 5y, and lastly plus 4. This is the quadratic form. And now when you put this in the calculator, I'll show you right now. Let's solve it up. It's by mod 5 and quadratic is by 3. And now the coefficients are 1, minus 5 and 4. I'm going to get two values. One is 4, okay? And one more is 1. So I get y is equal to 4 and 1. Now here I can easily understand the first one. This one is at 1 because it's corresponding towards 1, and the upper value is 4. This is beyond the limit. I don't need that. Only 1 is enough. So the limit over here from the base 0, that is the lower limit, and 1 is the upper limit. So here integral, it will be 0 lower limit till 1. Now all these, I'm just doing these cross sections from 0 to 1. We are making sections and we are adding up to find the area. What is the right side equation? It's 2 minus x, but we cannot put 2 minus x. We need to put it in terms of y. This is the equation over here. It is 2 minus y minus, what is the left equation? Right minus left, isn't it? Left is root y. Now this dx, this is it. So I'll just put this in the calculator here. To use definite integral, you have to use this symbol here, definite integral symbol. Type it out. You can use brackets for the first term. It is 2 minus, you can't put y as the variable, just put x itself, but you should understand it's y. Minus square root x, variable x is by alpha, and the closing bracket symbol. Now here you can put 0 until 1, and that's the answer. What's the answer here? Might take a few seconds, and it's 0.833. That's the final answer. So that will be the area, that is 0.833 units squared. Because we don't know what exactly is the unit, just write unit to the power 2. So that would be the final answer. Now I'll show you the detailed way to write over here would be sketching the graph. See, our graphs were not accurate enough, okay, but still it'll give you the complete final answer. See, it's similar to it, but any rough graph is okay. That's more than enough. And then we're going to rearrange these equations and write over here, and then to find the point of intersection, just solve both of them together. Now here it's squared up, and then the equated, solved it up over here. This is the answers. And then what you do is substitute the values in the formula. Now the right equation is 2 minus y minus the left equation is root of y. The answer is 0.83 units squared. This is how easily you can solve this up. Please do try the other problems by yourselves. And if you understood the first question thoroughly, you can just skip do it by yourself, skip it off, move to the next topic. But I'm going to solve all the problems here now. Here you can see the area bounded by the graphs. X is equal to y squared and x is equal to 2 minus y squared. Now, if you know the graphs directly like this, I will tell you some of the pointers. You can make it changing this to the other side, y is equal to square root x, but this becomes more complicated. But since it's quadratic, I will tell you, x is equal to y squared means what exactly is? It's a parabola. If it was y is equal to x squared, we do it upwards. Y is equal to minus x squared is downwards like this. But if we have yx is equal to y square, positive is the right side, and x is equal to y square, negative would be left side. These are the things you should know about this parabola. So now if you know that, then we can easily solve it up. How? Plus is there, right? It'll be something like this. Here it's minus 2, that's fine. It'll be something, since it's 2, it'll be moving 2 to the right. This point will be at 2, this is at 0. That's it. But even if you don't understand that, you will know graph something like this. Now, what are the intersecting points? That's fine. Just equate them both and you will solve it. We will solve it in a minute. But which is the right equation now? The right side here, it should be 2 minus y squared. Left side is y squared. Let's find the points of intersection. We need both the points now. Graphing is done. So now make x is equal to x, that is y squared is equal to 2 minus y squared. Bring it inside, it will be y squared plus y squared is equal to 2. Or 2y squared is equal to 2. Divide both the sides by 2, you're going to get y squared as 1. You can put this as mod phi 3 and solve it. But it's so simple that it's y squared equals 1 means take square root on both the sides. Y is equal to plus or minus 1. This is the answer. So the limits are a will be minus 1, b will be plus 1. This point over here is minus 1, plus 1 for y. Okay, so it's almost done now. Integral, right function. I'm not going to write the formula, I'll directly do it. It's 2 minus y squared minus left function is just y squared dy. Remember the formula and the limits are minus 1 to 1. Now put this in the calculator, you should directly get the answer. So please do try it by yourself in the calculator now. Let's look into the answer. It's just like this, 2 minus y squared minus y squared minus 1 to 1, and that would be your answer. So this is how we solve these. And here we have again similar problems. Now this time the equations are given as y equals x. So when we convert them, this is going to be x is equal to y. But what happens over here is, it'll be x is equal to 2 minus y. And over here it'll be, sorry, we just now did this, example problem. So it's the same thing. Let me just show you. Yeah. My apologies. We had done similar problem, but over there it was y squared. Over here it is x is equal to y. So the difference is it's a linear line, and a flat line over here. So this is the bounded region. Same like what we did just a while ago, we are going to follow the same thing. Y is equal to 0. So what you do is, you rearrange this, right? How would you find the point of intersection? Just solve these up. Y is equal to 2 minus y, take it to the other side, it will be 2y, because it will be plus y plus y is 2y equals 2, y is equal to 1. So we know there is only one point of intersection and it's at 1. So limit is 0 to 1. What is the right side function? It's 2 minus y dy. Put this in the calculator, you're going to get the answer. Let's do this. I've typed everything in the calculator as it is and just make it equal to 0. So the answer must be 1. Let's look over here. Yes, the answer is 1. Now here they have used the limit formula by integration. That's also fine. Or if you write all the details and just do it in the calculator, it's also fine. So this is the formula. Getting the formula is most important. Now over here they have just simplified, multiplying this minus over here, minus and minus will be 2 minus 2y. And limits are written. They have integrated. Integration of 2 is 2y minus 2y squared. 2 y square by 2 and 2 cancel, so we get y square. This can be done. But it's very important to get the graph and the changing of the equations and then putting the formula and then solving it out. Now, since it's all linear over here, straight lines, you can also use area of a triangle. That's half base into height. Base is how much? 0 to 2, that's 2. Height is 1 and half is the constant in the formula, so you get 1 itself. Similarly, please do try these. The worked out solutions are there. You need to draw rough sketches of graphs and then you need to convert. See now, y is equal to x. What does this mean? It's a 45-degree line. Then y is equal to 2. It's a straight line at y equals 2. Y is equal to 6 minus x. So wherever 6 is there, this is 2. So 6 is above. We draw a line downwards. So this is x minus 6 minus x. And y is equal to 0. So whatever is formed, that is a trapezoid over here. Now I'll just show you. What you can do is, you can understand from here, if this is 6, high up above, and then over here you have 45-degree line, that will be something like this. But now here this touching point is above. You can easily find it by intersection, but there is another thing. Y is equal to how much? Y is equal to x. Y is equal to 2. So you need to cut this, and then y is equal to 0. So this is the thing. Here the limits are very easy. Why? Because we know the base is at 0, y is equal to 0, and this is at 2. So the limits are 0 to 2. So we don't need to solve the intersection at all. From the figure itself, you can get 0 to 2. Substitute, solve it up. This is how we do it. Now if you're using integration formula, integrals formula, you can easily solve it up like this. Use the power rule. 6y, 2y square by 2, that 2 cancels, it will be y square, and then upper limit first, it will be 6 times 2 minus 2 square minus the lower limit 6 times 0 minus 0 square. So that would be the answer. And since it's all linear lines, again, yes, you can use the area of a trapezoid. It's half. Now this is the upper base, lower base, AB multiplied by A plus B multiplied by the height. And that's the answer. Similarly, please do try these problems. Over here, it's a little bit touch and go, but you can see the right equation function would be this line. And then the left is the left side one. So here, this is the 3y and left side is 2 plus y squared. Always remember to convert. If now here it's given as x is equal to 2 plus y squared easily, but otherwise if it was given as y squared something, convert it to x is equal to and then use it in the formula. For this 16th question, formula will be the same. It's all with respect to y as variable x. So always remember it will be dy over here. And this is how we solve it up. And over here we have the last problem. Again, it's a simple parabola, but it's x is equal to y squared. Since it's positive, it will open up right side and x is equal to 4. So over here. Now what you need to do is you need to equate them both and find the limits. So it will be y squared is equal to 4. Y is equal to square root 4. Y is equal to plus or minus 2. So this is minus 2. This will be plus 2. So integral minus 2 to plus 2. And what happens? The right side is 4 minus left side equation is y squared. That's it. Put in the calculator. You're going to get the answer. Definite integral solving. That is the end of this topic. If you have any questions, any doubts, any clarifications, do post them in the comments. I would also highly encourage, if you see any doubts by any other students, try to answer it by yourself as well. I sometimes see in some videos, students do clarify other students' problems. That's a great thing. I would try my best to get back to you on the comments, but if you can, please do answer to others' doubts and questions. Question 17 is to find the volume by the method of washers. It is very important which method is used because the question number 3 is same problems but it is method of discs. In this video we will see the difference between both of them. Method of washers is when a hole is created. As you can see, this is the details. Now imagine this is the part of the given equation, given graph, that is being revolved along the x-axis. So what happens? This part is turned over here, it comes up, and this happens, right? But you see, we are considering this as a circular cross section. So this entire thing over here is a full circle. But as you see, as we move from here to here, there's a hollow space that is generated. See, this is the hollow space that is being generated. So what do you understand by this? This hollow space is something that is not required. Now if you look in such way, over here there is a hollow space at one particular cross section. Okay, imagine this is the cross section. So I need to find this volume only. So what I do is I'll find the total volume, that means the entire thing, and I'll subtract this part. Whatever is this, I'll just subtract it off. That time I'll get whatever is outside. So this is the formula. It is the outer radius minus the inner radius. That is how we can find whatever is only formed. Okay, the hollow space is removed. The hollow space created makes it a washer. Washer is having something hollow in the middle. Now we need to understand which formula to use depending on the question. So depending on which axis it's being rotated, if it's along the x-axis, okay, it's rotated along the x-axis anyway like this, or y is equal to 2, 1, 3, or along the x-axis. This is the x-axis. You use the first formula, and over here the limits, right, is along the x-axis itself from here to here. Whereas if it's along y-axis, that will be like this vertically, like say this is the rotation, or along this line it's being rotated, then it will be the second formula. So it's very simple formula: pi, definite integral, outer radius minus the inner radius squared, both the radiuses, dx. So we will see a problem here. Now what you need to do is let R be the region bounded by the graph over here given. These are three graphs. Compute the volume of the solid form by revolving about the x-axis. Now let us solve this up. Now this is a basic graph that we are going to use. Let me just draw a simple graph. X squared means it's a parabola. X is 0 here, so it's this vertical line. Okay, if it is x is equal to 1, it would be a vertical line, so I'll just consider this. That is a very bad line, so just remember this axis. And y is equal to 1. Let's imagine this is at 1.1. So this is being revolved. Where is it revolving? About the x-axis. So here. So this thing forms something like this. As you can see, this is what is formed. We just now saw the figure. Now here what happens is, if you see this extension, it will be like a circle over here, and this circular region, the washer region, it varies. If I'm considering this part, it's almost full out. If I consider somewhere over here, this over here is the hollow region. Somewhere over here like this will be the hollow region formed. Since we are revolving it, it rotates. This part keeps on coming up and it rotates. It becomes like a circle. So that's the thing. We need to imagine this, and then we need to understand this up. And now what we do is we will try and solve it up. What do we require? We need to see from the figure which is the outer radius. Now since it's along the x-axis, it's very simple. Outer radius is this flat line, right? Outer radius is capital R, that's 1. What is the inner radius? It's an equation. It varies. At each point it varies. So it's given as this equation. Inner radius is given as 1/4 x squared. Okay, this much is fine. It's revolved along which axis? Along the x-axis. That means like this. So which formula do we use? Now here it is very important. Now you can look at this and understand. Since you're rotating along the x-axis, you need to consider the limits on the x-axis itself. Now this along the x-axis means the formula will have dx. Now everything must be in terms of this. Now what you need to understand is, we know the limit x is equal to 0 is considered. Okay, this is 0. But where is the end point? Where does this touch? This is at 1, right? And now you can see this equation will touch over here. So this x point is also required. Why? Because we need to take the limits. 0 is the starting point. Yes, okay, that's fine. But we know y is equal to 1. We don't know where it ends at x. So this is an issue. So what you need to do is you need to find this intersecting point over here, this point. How do you find this? We need to equate this. What is the equation over here? Y is equal to 1, and over here we have y is equal to 1/4 x square. Let us solve this up. 1 is equal to 1/4 x square, and if you take this to the other side, it's going to be 4 is equal to x square, or x squared is equal to 4, x is equal to plus or minus 2. So this is what we need to solve for. I mean, this is what we get over here. So this x over here is 2 and minus 2 is somewhere over here. We won't take that because we're not considering the left side, we're just considering the right side. This is it. Now what next would we do? Here we found the intervals 0 to 2. We know the outer radius, we know the inner radius. Just put it in the formula and solve it up. So I'll just use it over here. Integral. So pi is outside, volume is equal to pi. Integral 0 to 2. Outer radius, it's 1 minus 1 squared, minus the inner radius. What is the inner radius? It's 1/4 x squared. This is entire square, dx. Put this in the calculator and you will get the answer. Let's have the calculator with us. Now all you need to do is write pi first. Pi integral, it is 1 square minus, now here because we have to square it, remember use the bracket, that's 1/4. Wait a minute, I just realized that I've written this wrong. It is 1/4 x squared. The equation is 1/4 x squared and then again the whole square, okay? Because the formula itself tells you it is outer radius square minus inner radius square. RORI integral a to b, outside is pi, and this is dx, right? Now this is the entire thing will be squared here, okay? So 1 square, that's fine, 1 and squaring. Now here 1/4 x square, the whole square. I hope that is clear. So I'll just write alpha x square, close the bracket, and over here first square it, then close the bracket, again square it, and the limits are from 0 to 2, and that's the answer. It is 8/5 pi, or it's 5.02. So we will see the answers over here. You can see this is how it happens. Now 1/4 x squared and x squared by 4 is the same thing, so that's how we get it. Now we got two values of x, so we ignore the left side because we're considering only the right side here, so that's the thing. And here the limits are given, and then we put it in the formula and we solve it up. 8/5 pi, or 5.03 unit cube. Why? Because volume is in terms of power 3, the dimension. So it will be, if it's centimeter, it'll be centimeter cube, and so on. So that's how we solve this particular problem, and we can solve other problems. Now we will just go through this and then we will go through these problems and solve as well. Same sketch, same graph, but it's not along the x-axis. Now we are rotating, it's along y is equal to 2. See the same graph which we just now got. Over here they have given y is equal to 1, so this is cutting out, and then x is 0, so this is the part, and then what do we have is 1/4 x squared, so this is the thing, okay? This is what we are rotating here, not along x-axis, not like just now what we got, along the line y equals 2. So you can see this is the line y is equal to 2. Over here it's been rotated. Now what is the issue if we rotate it over there? There is so much space, right? The same thing, now when you start rotating it, this part comes up, so the same space is left hollow over here also. Now this was how much? From 2 to 1. The line they have told y is equal to 2, and we know it cuts at 1, line y is equal to 1, so much will be 1. It's very simple. Same thing over here also, there will be 1, and then we will have a straight line, and then over here also the straight line, and then this thing. This is how the figure actually is, and this is the hollow space formed. So now we are not going to consider both the sides, we're just focusing on one because we are considering radius. If we consider the entire thing, it will be diameter. We're not taking inner diameter, we're taking inner radius. So from this rotation point, where about which line we are rotating, right? From here to the inner part. Now inner part is flat, isn't it? It's a flat line. So from here to here, how much is the distance? 1. So that's it. Inner radius is very simple. That is inner radius. Now the outer radius is very important. The inner radius is easy to find. Look from the point where it's being rotated or revolved. See the outermost point of the figure. It's still over here, right? What is this distance? We know from here where it's rotated from this point to this point, it's 2. But you can see the curve is coming inside. So it'll be 2 minus whatever is this equation. That will be 2 minus, what's this equation of this curve? It is 1/4 x squared. So this must be the outer radius, outer, yeah. Now, if at all it was like this, imagine this is where we rotated, and this one, 2, and the curve was going outside like this, just in case. Then we would have taken it as, sorry, it would have been something like this. We would have considered to be 2 plus. We will see such problems. They'll give you specific problems like that. We can easily deduce how to take the outer radius based on that. Now over here, see these 2 points. Okay, from here to here, it's 2, but it's coming inside. So here there is a decrease, right? So we consider minus this equation because it's coming in. So now then we have the outer radius and inner radius. So the formula is very simple, pi limits. The limits are going to be the same because we just now solved it. It will be from 0 to 2. And how do you solve it is very simple. Just solve these 2 equations, you'll get it. And then what do we have is outer radius. So outer radius is 2 minus 1/4 x squared, the whole square, minus inner radius is 1 square. This entire thing with respect to x. And what will be the answer? We will do it in the calculator. I've just typed this equation in the calculator. You can see it's pi's, limit 0 to 2, 2 minus 1/4 x squared, the whole square, minus 1 square dx. And when you press equal to, the answer is over here. So let's look into this problem. Here you can see this is what happens after it revolves. This is the hollow space formed. And over here, this is the outer radius, inner radius, and limits are again 0 to 2. And you solve it up. And yes, 56 by 15 pi is what we got. It's 11.73 unit cube. Please do try the problems, other problems by yourselves. Now here, let us see the difference between which is the washer and which is the disk. Here we have a problem of region being bound at 2 minus x, y is equal to 0, x is equal to 0, about x-axis and about y is equal to 3. So now, over here they have just given the answers, they have not done the figure. So let's do the figure and then understand. Here for the first one, it's very important to understand the basic graph. 2 minus x, it's basically like minus x plus 2, so wherever is plus 2 is the intercept, and it goes something like this. And what else do we have? Y is equal to 0, so this will be y is equal to 0, this part, and we have x is equal to 0, so it will be this line. So whatever is intersected between, or the region formed within this, this is the region that is being revolved. Where? About the x-axis. About the x-axis is over here. Now if you revolve it along the x-axis, what just happens? Here you're gonna get the same thing down, right? So there is no hollow space formed at all. So this is a disk basically. It is not at all a hollow space, it's just a disk. So just find the radius. Over here y is equal to, this is the radius. So now imagine you have a circle and you just have the radius. It's like there's no hollow space. You just do pi r square, and if you integrate it, you get the volume. It's very simple. Only when there's a hollow space, what you do is, now if you want to remove this, the total, now imagine this is capital R, you do r squared minus pi r squared, the small letter r. Because there are 2 radiuses formed, you want to remove this. That's why we do minus. But now in this case, you don't have to subtract anything because you know the radius, right? What is the radius? This is the radius. What is that equation? 2 minus x. So it will be pi r square. The intervals are need to be found out. How do we find that intervals? From here to here along the x-axis, because it's dx, it's along the x-axis. This is 0, but how do you find this? It's by equating this equation 2 minus x with, what is this equation? 0. So solve for x, x is equal to, goes to the other side, x is equal to 2. So we know the limits are 0 and 2. That's how we get the limits. And then over here, there's only one equation to use because it's a disk. But now the same thing, what we just now found out, right? Here, when it's rotated along y is equal to 3. So I will just change the figure. Let me do it down. This is over here 2, right? Now we are rotating along 3, y is equal to 3. What happens? So here we need to leave a space, and then it goes up like this, like this. So this is formed. When you're rotating, this comes up, right? See, now it's like rotating it. It's more easier to show it, by rotating stuff. Usually I show my students something that I keep my hand as the axis, and then I move an object over here like a duster, and it comes up and it creates a hollow space in the middle, right? So that's the thing. So if I consider this as the section, this is the hollow space created. So that is the thing. That's a very rough diagram, but you need to imagine it. Okay, then only you will understand these problems. So here, because this hollow space is created, now you need to realize what is the inner radius and the outer radius. From here, since this is being the axis of rotation, very important to focus over here. Let's see the outer radius first. Outer radius is a flat line. That means it's constant. So how much is the radius? Instead of taking it up, it's better to go down. Why? Because you know it starts at 0 and 3, so outer radius is 3. What about the inner radius? Inner radius is also 3 minus this equation. Why? Because it's inside, right? 3 minus it. This is what we are revolving. So this one. So outer radius is 3 minus this inner equation. So it will be small letter ri. 3 minus, what is that? 2 minus x. So it's going to be 3 minus 2 plus x, that is 1 plus x. So this is the equation. Now you just put that in the calculator in the formula and you will get it get the answer. So I'll just erase this for a while. You can see the outer radius, what we found. Outer radius RO is 3 minus the inner radius is 1 plus x, isn't it? 3 square is 9 minus 1 plus x, the whole square. This entire thing will be squared. So this is it, and that's how you can easily get the answer. Now you put this in the calculator, you directly get this answer. But if you do the diagram, see, now let me just go back here. If you do this diagram, like a rough diagram, if you write the outer radius separately, inner radius separately in detail, it's more than enough. You can just use the calculator to find the final answer. So I hope this is clear as well. Now let's do one more problem here. I hope this is in terms of, yes, this is along with respect to dy. Okay, let's do this. The region is bounded by y is equal to x squared. Now let's draw a rough graph. Y is equal to, sorry, not x squared, root x. I'm just maybe sleepy, So it's a root x. What happens? Y is equal to root x will be something like this graph, and y is equal to 2, so it's somewhere over here. Okay, and x is equal to 0, that means this part. So we have to focus on this region. And here about the y-axis, if you're doing about the y-axis, that will be like this. Again, this will be a method of a disk. It's a disk problem in question 3. Now we will not look into this. Why? If you do it along the y-axis, it's just going to be like this. Left side, sorry, also same, and it's a single thing. There is no hollow space form. But we need, if we do the part B, we need washer, right? X is equal to 4. So now this one, I think so it's less than 2. So let me just take it somewhere over here, okay? X is equal to 4 is this line. If you're rotating along this part, so this much is again over here also hollow, and then it comes like this. I hope that's clear. So this is how it looks. Now it's along the which axis? Now it's rotated x along the y-axis because x is equal to 4. It's along the y-axis it's being rotated. So this part rotates and comes over here and keeps on moving like a circle. So here limits are not along x, it's with respect to y. So we need to find this to this limit. Now what is the limit over there? We know it starts at what? X is equal to 0. Up, where is this point? 2. So it's very simple to get the limits. It's 0 and 2. That's it. Now, the thing is about outer radius and the inner radius. Now, it's not from down to up. It's not like this. It's the other way around. It's horizontally. So from here to here, the outer radius, how much does it? How much is it? I will take this because this is easy to understand. It's 0. X is equal to 0. This is x is equal to 4. See this part? Now, because we are rotating it along x is equal to 4, I just drew this part. But if you do the left side, only one part it's enough because we just need the radiuses, right? From here to here, outer radius RO is equal to 4. Now, what about the inner radius? It's 4 minus this equation. What is that equation exactly? Here now, you cannot write in terms of x. I can't write root x. No, why? Because we are doing with respect to y, so we need to change this. So square both the sides is going to be y square is equal to x. So x is equal to y square. I should write 4 minus y square. This is the equation. So the outer radius is 4 square minus, there is pi here, minus the inner radius, it's 4 minus y, the y square, the whole square. This is it. So this is inner radius. It's 4 minus y square, then put the bracket and the whole square. Okay, I'll just rewrite this properly. The inner radius would be so much, but the formula states whatever is the inner or the outer radius, it must be squared. Let's use the calculator and solve it up. I've just typed this equation as it is. It's pi 0 to 2 limit 4 square minus, when there is more than one term, please use the bracket, 4 minus. There is no y term, y variable in calculators, so write it as y, but in the calculator just put it as alpha x square whole square dx. What is the answer? It is 224 by 15 pi. Let's check the answer. See, the first one I did not do. Why? Because along the y-axis it will be a disk problem. We will see in the question 3. But here it should be, yes, that's the answer, 224 pi by 15. Please make sure you draw a rough diagram. I'm not saying for the marks or anything. It's for your own understanding, because if you don't do this graph, it'll be very hard for you to understand the outer and the inner radius, and you just can't memorize it. It's very difficult, so please try to understand this. Now similarly, you can solve the other problems. Please do them by yourselves. Now here you can see some problems. This is a disk problem, but very important to understand with respect to what. If it's with respect to y, then whatever is the equation, you need to write it as x is equal to, this goes to the other side, will be 4 minus y divided by 2. So that is what is done. But if it's along the x-axis, then you take the same equation, see, pi into 4 minus 2x the whole square as it is. But these were along the axes, so it will be a disk. See, why is it a disk? If you rotate it along the x-axis, what happens? This is the thing. There's no hollow space. If you rotate it along y, no hollow space. But if you say rotate it after certain distance, as you can see here, at y equals 4, that means over here, see, then there is hollow space formed. Y is equal to 4 means over here, see, this much is the hollow space, right? This will go up. See, the hollow space is created. So if you draw this, there will be a hollow space as well. So that's why we use the formula which we just now did. It's the same way. Please do these problems over here. The worked out solutions are also there. Just be careful. See, over here the figure is given. So analyze the figure, understand how it's revolving, and then solve it up. Now, if at all it is, say, x is equal to minus 2. Then at minus 2, this is 0, right? At minus 2, somewhere over here, you need to draw a line and understand this is the hollow space. Now, same thing will be over here, projected over here. So inner radius is how much? From here to here will be 2, and outer radius would be, see now this is important. What is the outer radius over here? It'll be 2 plus this equation. But remember, we can't write this equation as y is equal to, because x is equal to 2 would be integral dy with respect to y, isn't it? Along y-axis, this rotation, see, vertically. So we need to rearrange this, plus this equation would be 4 minus y by 2. So this would be the thing. So now what we can do is we can solve it up, or you can use it directly in the calculator. So you can see this is the outer radius. Now we have simplified. So let's just simplify it. You take this denominator as 1. So let's take this as 2, and over here there's 1 times 2, it will be 4, plus this, the denominator 4 minus y. The answer would be 8 minus y by 2. So you can see this is what's taken. 8 minus y by 2, the whole square, minus what is the inner radius? It's just 2 minus square. Now you don't need to write this pi inside, you can just write pi outside at once. Everything like we had used just a while ago, right? So I'll just do the last part over here. As we just saw, it was at minus 2. This is x is equal to minus 2. Radius is 2. So first, inner radius is equal to 2. That's it. For the outer radius, capital RO, it would be 2 plus this equation. Why? Because see over here, from year to year it's 2, but this is going outside of that, right? So I'll write 2 plus this equation with respect to as y as the function. So we have to just rearrange this. That will be 2x is equal to 4 minus y, x is equal to 4 minus y divided by 2. So that will be 4 minus y divided by 2. Now since it is improper over here, let's make it a proper fraction. 2 is the common denominator. Over here it's nothing but 1, so it will be 1 times 2, 2 times 2 is 4, and then we have 2 times 1, so we write this as it is. It's minus y, and then what do? Is we write it as 8 minus y divided by 2. This is the outer radius. Now if you want, you can keep the outer radius like this itself and square it. That also will give you the correct answer. Now the formula is pi integral. Now what is the limits along the y-axis? It's very simple. It's 0 to 4 over here. So 0 to 4, and what you write is 8 minus y by 2 the whole square, minus the inner radius is how much? 2 over here. Inner radius was 2 square. This entire thing is dy. Put this in the calculator, you will directly get the answer. So this is how we solve it. If at all you have been given the figure, it's so easy. Even if the figure is not given, you can draw a rough figure and then solve it up. Please do try more problems by yourselves. See, all the worked out solutions are there. Again, these are very simple. If there is hollow space, you would have outer radius minus inner radius. That is the method of washers. If you have only one thing squared, that means it's method of discs. So in this particular writing, you will only have method of washers. They have clearly mentioned washer part, so it will be outer radius minus inner radius. So only focus on those problems. And over here as well. And last problem over here, all the answers are there. Please do solve that. So that is the end of this particular topic, question number 17. I hope this is clear. If you have any doubts, do post them in the comments. Please be careful along which axis. I'll just reiterate again. Now, if at all the rotation is along the x-axis like this, x-axis means either it can be x-axis or y is equal to 2 or y is equal to minus 1, then the formula will be with respect to x as a function of x. It will be dx over here. Okay, so all this over here, whatever is there, it will be as 1/4 x square, or it will be minus 2x the whole square. I'm just giving a random example. It must be in terms of x. What is the limit here? Limit is along the x-axis from 0 to 2 like this, along x-axis. But if it is along the y-axis, or we have x is equal to 2, x is equal to minus 3, that means Here it's like this along this axis, or over here. When it's rotated like that, the formula will be integral. Here it will be with respect to y, so it should be y squared minus 2y, something like this, with respect to dy. So this is very important, and the limits over here is on the y-axis from here 0 to whatever, wherever it's ending upwards, that will be 0 to 4. So please understand the differentiation on that. From the question itself, you should understand that, and then you can solve it easily. Question number 18 is to solve problems based on arc length. Let us look into the arc length formula. Here we have a simple formula, that is integral from the limits a to b, square root of 1 plus, this is derivative f prime of x or f dash of x. That's the derivative squared dx. So the derivative is to be known, and then it is inside the integral, and you solve it up using the formula. Let's solve a problem here. You can see they have told a cable is hung, and they have given hyperbolic, that is generally used in mechanical engineering to exactly solve the detailed force, motion and everything. But for us now, they have also given it in simple terms, that is exponential only. And they have mentioned the cable is 20 feet apart. Okay, that's fine, from here to here. But we don't want that length, we want the arc length. They have told the limits are from minus 10 till positive 10. Okay, this is helpful, and the equation is given for this particular cable. Now, the reason for doing this particular example problem is the same problem is used in one of the other exercise problem as well. Now, what you need to do first is derive this function. How would you derive it? Derivation is y prime, that is phi is a constant, let it be. What is the derivative of e to the power x? I'll write a bracket over here. E to the power x is same, so e to the power x by 10 itself. But here, if it was e to the power x, the derivative is e to the power x, that's it. But if you have e to the power 2x, the derivative is e to the power 2x, then the chain rule applies. 2x is derivative 2. So the same thing must be done. Now here, instead of e to the power x, we have x by 10. So it will be e to the power x by 10 multiplied by 1 by 10. Why is this? Because derivative of x is 1 and this is constant. So we will have 1 by 10 plus, now what happens here is same thing, e to the power minus x by 10. But do you remember the derivative of e to the power minus x? It is minus e to the power minus x. Now what happens when we have e to the power minus x by 10? It's going to be minus e to the power minus x by 10 multiplied by 1 by 10. So here, or you can just derive this and get minus 1 by 10. Now why we write minus? Because the derivative of this minus x would be minus 1. So that sign is over here. This is the actual thing, but I've written over here in bracket. This is also fine. Whichever you understand properly, it's more than enough. Now we will have to simplify that. So let me just clear that off. Here it'll be phi constant itself, but I can see this 1 by 10 is common, so I'll take this out. It'll be phi into 1 by 10 or phi by 10. Here it's gonna be e to the power x by 10, and then we have this minus sign over here, minus e to the power minus x by 10. So this is the answer. You can simplify this 1 time, 2 times, so it'll be half and this term. So what we have over here is the derivative f dash of x or f prime of x. Now derivative is done. Now what is the formula? Integral a to b. Then we have square root 1 plus f prime of x dx. Now what is the interval over here? It's minus 10 to positive 10, and we have 1 plus f dash of x, this entire thing, just write it out. And oh, I forgot to square over here. That is very important. Square is required. So it's half into e to the power x by 10 minus e to the power minus x by 10. This I'll close it and square it up, dx. So this is it. I'll just put it in the calculator now and we can easily solve it up. I'll show you how exactly we are to put the integral symbol. Then we are to put the square root 1 plus, open a bracket over here. You can write half or 0.5 is the same thing, multiply. You're opening another bracket for these two, okay? So shift and natural logarithm function gives you exponential e. That's Euler's number. And then make the fraction symbol, alpha x by 10. And over here, write minus sign, shift e to the power, again alpha x by 10. But I forgot to write the negative sign over here. It's minus, and close the bracket. Go down now, close the bracket. And we need to close one more bracket and now square it up. And what are the limits? It's from minus 10. The lower limit is always down, the lower value, upper limit. And that should be the answer. It is 23.504. Let's look into the answer. See, you can write it in steps, I've just written everything at once. First, you need to derive this, write the formula, substitute it properly, and then solve it up. Over here, this is the given function, and derive it up. And over here, see, I've done in derivation in detail, so please follow that. Over here, it's directly done. And then using the formula, you just substitute it, and then you get the answer. It's rounded off 23.5 feet. So that's how we solve this problem. Now let's solve some more problems here. Again, it's all the same thing, but over here it's just that the rope is 40 meters and the limits are minus 20 to 20. Then they have given the catenary equation here, that is y is equal to 10 e to the power x by 20, and same thing. So let's directly solve it up. You can write it as y or function of x, f of x is the same thing. 10 into e to the power x by 20 plus e to the power minus x by 20. Now when I derive it, I'm going to do it directly. So I know 10, and this will be 1 by 21. Okay, let me just do it in steps. You can directly solve it by just dividing this by 20 and getting it out, like 1 by 20 can be taken out. But the steps are over here, e to the power x by 20 multiplied by 1 by 20. If you're thinking how this came, the derivative of e to the power x by 20 is over here, and then the chain rule, x by 20 derivative is x is 1 by 20 plus, now I'll directly write it's minus. Why? Because there's minus over here, so it'll be negative. E to the power minus x by 20 multiplied by 1 by 20. Now that's enough, but you can simplify it. It's better to simplify f dash of x. Over here, what happens is this 1 by 20 and 1 by 20 comes out, so it becomes half again. And we have e to the power x by 20 minus e to the power minus x by 20. That's it. Now let's use the formula. It's square root 1 plus derivative. I'll just write the formula first. The whole square dx over here integral a to b. This is the arc length. And now what are the limits? It's from minus 20 to positive 20, square root of 1 plus your half times e to the power x by 20 minus e to the power minus x by 20, the whole square dx. I hope this is clear. And what do we do here is just put in the calculator and you can solve it up. So I've just typed everything, entire equation in the calculator, integral minus 20 to 20, and over here it's 1. Open the bracket, half times. I've written this equation and close the bracket 2 times before squaring it, because 1 is this bracket and then the outer one for square. And then the dx will already be there, and that's it. And press equal to, that is the answer. You can even try doing this by, formula method, but it's just going to take a long time. Just use the calculator. It saves a lot of time. As long as you have written the derivations properly, the formulas properly, everything substitution properly, it's more than enough. You can try even squaring this up, simplifying it, and then using the calculator. Maybe 1 or 2 steps Square this will be 1 by 4th, and over here it will be 2x by 20 minus 2x by 20. And oh, sorry, this needs to be when you're squaring this is direct, but over here you need to use a minus b the whole squared formula, which is a squared minus 2 times ab plus b squared. So use this formula and then you can simplify as well. So, or directly put in the calculator. Let's look at the answer. Yes, it is 47, nearly 47 feet, or whatever the dimension is. It's meters. Similarly, please do solve the other problems. It's just like that. You can solve it by yourself and then find the answer over here. Check the answers. And the last one over here is interesting. Here they have told in the example 4.4, which we just did a while ago, this figure was there. Compute the sag in the cable, that is the difference between the y values in the middle, that is at x is 0, and at the poles, at x is equal to 2. Given the arc length calculation, surprising. Now, given this, is the arc length calculation surprising? Now, what we need to do is, first let's find the sag. Sag means, see, over here, imagine the cable is tied and tied. It doesn't stay flat. It doesn't stay exactly horizontal. It'll sag because of the weight of the cable and it goes like this, arc length. It sags. This is called sagging. Now, what we need to do is we need to calculate the sag. How would we calculate this? Now, if you remember the equation, see, we need to refer to the 4.4 question. So this was the equation given. We had solved it, we derived this. So to find the sag, let's find x of 0 for this particular equation. Instead of y of x, I'll write f of x. F of 0, what is it? So what was the equation? It was phi e to the power, instead of x, now here the question, over here I'll write 0 plus e to the power minus 0 by 10. Now you just put this in the calculator and you will get the answer. So what is the answer over here? It will be phi, anything to the power 0 is 1, plus over here again minus 0 is neutral, so it's 1. So phi times 1 plus 1 is 2, that's 10. So the answer must be 10, yes. That means this, for this equation, this length is how much? It's 10. So now let's do it at the poles. So we can see it's about 15. So the sag is about 5. But no, it's not 15, it's 15.43. So we need to find it again accurately. So now what we do is f of 10. Same thing, instead of x, I have to just substitute 10. Now here it will be 5 times e to the power 10 by 10 plus e to the power minus 10 by 10. And over here, what's going to happen? It's going to be e to the power 1 plus e to the power minus 1. You just have to put this entire thing, see over here, this in the calculator. And when you solve it, you'll get this answer, 15.43. That means over here it was 10, here it is 15.43. What is the sag here? It's 15.43 minus 10, it's 5.43. That is the sag. So this is how you find the sag, but they have also asked you to estimate the arc length, right? Now we are not doing the derivation. We know this much is 5.43, right? What is this length, vertical? So this is, corresponding to 10, because it's told it's a 20-meter cable. At the center it's 0, so this much will be half of 20, it's 10. Now how would you find this arc? We can use Pythagoras theorem to estimate this. We'll just estimate it. So Pythagoras theorem is the hypotenuse, the longest side. This is the hypotenuse C. And if you imagine this is A and B, it's given as C squared equals A squared plus B squared. So in order to find C, you just have to take square root on both the sides. It will be A squared plus B squared. So C will be square root of 10 squared, sorry, it's 5.45, it's the same thing, squared. Here now this is the arc length, but over here it's on the side as well. So whatever answer you get over here, you just multiply it by 2 to get the estimate of arc length. Let's look over here. See, it is basically square root of 10, that's the length over here, and the sag is given as 5.43. square them both. And why is this 2? Because it's both the sides, right? So you multiply it by 2. The answer is 22.76. If you recall, we had got 23.5 meters using the derivatives. So what we found out over here is very, not accurate, very close enough. That's what you can say. So that's how you solve this problem. That's the end of this problem. I hope this has been helpful. Just remember the formula. Derivative is very important and squaring the derivative is important. And then we can just use the formula and solve for the arc length. Moving on to the question number 19, it is to use integration by parts to compute definite and indefinite integrals. This integration by parts is very important. There are some problems which cannot be directly integrated. We don't have formulas, and then we use this. This is given by a formula. This is it. It is integral of u dv equals u times v minus integral of v du. Now, if you're thinking, why do we need to consider u dv? You can consider anything else. You can consider this to be m and this to be n, dn. It's fine. But you must remember that these both are separate terms. They're not related to each other. What I mean is, you have to solve them separately. Whatever is considered to be u will be derived, dv will be integrated, and we find out this v. So from the given question itself, we do it. And then these three terms, u, v, and du, are found out from these assumptions, and we use this formula. So now let's look into a problem. Here we have x sine x dx, integral of that. Do we have any formula for this? Just take a moment and think about any formula which you can solve. We don't have, because it's basically multiplication over here, isn't it? If it was differentiation, we have product rule. But this is integration. We don't have any rule over here. So what we consider is, we have to assume some term to be u, some term to be dv. Now the selection is very, very important. If you do the wrong selection, it'll not give you the correct answer. So which will you select to be u? See, take a term which is easy to derive. But more importantly, it's this dv term. See, remember, whenever you integrate it, this dv must not be complicated. See now, integration, right? Over here, what happens? Integration of, there's nothing, it's 1 dv basically, is v. So you're getting the v term. Now, some students get confused. How did that happen? Now, imagine you have dx and integrate this. What is the answer? It's x. Or why? Because you're integrating 1 with respect to dx with respect to x, so you get x. So same way, if I integrate 1 with respect to, say, theta, you're going to get theta. Integration of nothing, that is dv, means nothing, that is 1, gives you v. I hope this is clear. So now this is how we get v. But now v is fine. What do we assume to be dv? This is a very important thing. Now here, let's just for a moment, let's integrate both of them. What is the integration of x? Integration of x with respect to x will be, this dx will be over here. So which term, sine x or x? Integration would be x squared by 2 plus c. We don't write plus c over here. At the end, we will add it up. Whereas integration of sine x, what happens? Dx will be, it'll be minus cosine x. That's it. So this is almost the same, but over here, if you integrate this, if you're considering this to be dv, you're increasing by a power and it becomes much more complicated. So please don't use x. Why? Because you're complicating it more. So what we will consider is, we will consider it to be sine x. So here, sine x. Now integration of this will be minus cos x. So what is remaining here? It is x, and du with respect to x will be 1. Or you can just take it as, you can just write du is equal to dx. So this is it. So now we have all the required. Let's write the formula. Integral of u times dv is given as uv minus integration of, the first term is again v itself. This v is there, right? It's again over here, times du this time. Now let's substitute all that we know. U is x. What is v? V is negative cosine x minus integral. What is v? Again, it's same thing, minus cosine x. What is du? It's dx. Now let's simplify. Here it will be negative x cos x. What happens here? I can remove this negative sign outside because sign doesn't make any difference. If there is sign or you remove it out, you can multiply it later, that's fine. But when I remove it out, it's going to be plus. Why? It's minus and minus is plus. And integral of cos is what? Sine x plus c. Since constant, we didn't write over here the constant. Why? Because ultimately we're going to add a constant anyways. So that's it. Now here, this is the answer. So this is how we do it. Let's look into the step details. First, you need to analyze which to choose. So you need to do this u and dv. And then you need to derive both of them and get it as u dx. And over here, right side v is minus cos x. And then you just put it in the formula over here. And once you put it, you're going to get this answer. We got the same answer. Yes, that's correct. So this is how we solve it up. I hope this is clear, but this is not the Heikel problem exactly. I just want you to know, be thorough with this selection part. Now over here we have natural logarithmic x. Why I did this is the last problem, the 14th problem, requires this knowledge. Now you might have memorized the formula. If at all you're memorized, the answer is, okay, I'm a bit rusty now. It's x natural logarithm x minus x plus c. I think so. This is the answer. So sometimes we can memorize it, but actually how we do it is, how we find this is by u substitution. So here, this is not directly given. Now, many of you may not remember this, but now we will solve this up, okay? Here, what you need to do is consider it to be u dv. Now, which is u? We do not know. See, now if you do not know this integral of ln x, obviously you can't take it as dv, right? So take natural logarithm always as u. Whenever you see natural logarithm and like this, you're supposed to take u as ln x. Okay, I will call this natural logarithm as ln x, or you can call it as ln. Okay, and now what is du? It's 1 by x. That's it. Du by dx, sorry. And I want only du, so I will take the dx to the other side. It's going to be 1 by x dx. So this is the u part. Now what about dv? Now dv is going to be, see, this is taken already. What is remaining? Just dx. Basically it's 1. Both the sides it's 1 and 1. So let's integrate both the sides. You're going to get v equals x. That's it. Now let's write the integral formula. Integral of u dv is given as u times v minus integral of v times du. See these formulas, please write and practice these problems. If you write it a couple of times, it will be thorough, imprinted in your mind. You know, you will not forget this. So now what we do is, we see what is u. U we assume to be ln x, v is basically x, and minus integral of x into what is du. Du over here is 1 by x dx. This cancels, so you're basically having x ln x minus integral of dx. This is 1 basically, there's nothing, right? So the answer would be x ln x minus x plus c. So when you integrate this, it's going to be 1 is x plus c constant. This is the answer. So I hope, yeah, that's the correct one I've written. So I hope you remember, this is how we find the integral of natural logarithmic x, by integration by parts. That's the method. So here you can see in detail how we have done. And this is the thing. See, I've written over here, choose u term which is easy to differentiate, choose dv term which is easy to integrate. But it's not just that, you need to also understand the the consequences of choosing which and which. If at all I had chosen dv as ln x, now if you don't know the formula, it's just not possible. And even if you know the formula, it's It's going to be complicated. So always try and see which would go well, just a couple of steps, and then finalize with the u and v terms. Now, if you solve more problems, you naturally will understand looking at the problem, okay, u is so and so. Now, if it's e to the power x, you generally take that as u all the time. If you have trigonometric function, sine or cosine, you take it as dv. Now, this problem here, because you have e to the power x sine power 4, sine 4x, this keeps on recurring. Okay, we will see now when we solve it. What happens is when we use the integral by parts, that is u dv is equal to uv minus integral of v du, right? So here again the question or similar to this comes. So again you need to derive this integrate by parts. Inside integration by parts, again you have to do integration by parts. We will see it in a minute. Now whatever is the given question, let's assume it to be I. We will come to know why we are doing this in a while. So when you see e to the power x sine x, as a thumb rule, always take u as e to the power x. I hope this is clear. Always consider this to be e to the power x. So let's derive this. Du by dx is same e to the power x itself. And now we will write du as e to the power x dx. What about dv? The remaining terms. That is equal to sine 4x dx. I hope you remember this, the formula for sine integral of sine ax dx. If there is a constant before this, we have derived it in the lesson 7.1 already. So the formula is, we don't need to derive this again, it's just the formula, you have to memorize it. The formula would be whatever is the constant is written as a fraction, like 1 by a. And what is the integration of sine? It is negative cosine, so minus cosine ax plus c. So this is the formula. Now over here what happens is when you integrate on both the side, here we get v is equal to minus a is 4 here, 1/4 cosine 4x. We don't write c here, we write it at the end. So that is the formula which we use. Now then we have all what we need, u, du and v. So let's put it in this formula. So I, which is this given equation when we are integrating, this is I, is equal to, now you're just giving this as arbitrary, like a denotion I. You can take anything like a, b also, it's fine. But let's assume this to be I because we're solving this by integration by parts. Now over here, this is basically made as u and this entire thing is made as dv, right? So this is the same thing, these both. We have assumed it to be u and dv and we are solving it. Now what is u value? It is assumed to be e to the power x. Then what is v? So v is negative 1/4 cosine 4x minus, again v we have to write negative 1/4 cosine 4x. And what is du? It is e to the power x dx. Now let's rearrange and write everything. Here we can write the negative 1/4 out constant, e to the power x cos 4x. Then what do we have? This minus I will take it outside. It's fine. The signs can be taken and the constant term also can be taken. I'll write it as 1/4 outside. Integral. What is remaining? I'll write e to the power x cos 4x dx. Now can you see? It's similar to the question, but it's in terms of cosine 4x. That means we have to do it again now. We have to do integration by parts again. This side is done. We will do this side. And what's going to happen is we are going to get the question back. Now let us do it. Now actually, you have to assume over here again, u is equal to e to the power x. What is dv? It will be this. And then solve it. But if you're very thorough, you can try directly looking at the formula, directly solving it up. But since majority of the students may not be able to follow that, I will now solve this one only. Okay, this one. Again, I will assume u to be e to the power x. Du by dx would be e to the power x itself, and du is e to the power x dx. What about the other term that we consider to be dv? That will be cosine 4x dx. Integrate on both the sides, and we will be getting v is equal to, now here, what is the integration of cosine? It'll be sine positive, so I don't need to write the minus sign. Over here it was minus because integration of sine. So we have 4x, that's it. And now we will put it back into the formula. Now this part, integration of e to the power x cosine 4x dx will be equal to this formula here. U, what is u? E to the power x. What is v? It is 1/4 sine 4x minus integral again 1/4 sine 4x, close the bracket, and lastly what do we have? We have du, that is e to the power x dx. Now let's rearrange and write this. 1/4, I'll bring it outside, it's gonna be e to the power x sine 4x minus, let me bring 1/4 outside. What did we get over here remaining? E to the power x sine 4x dx. Now once look into the question here, what do you recognize? This question and this are same. That's why I assume this to be I, right? Now here I will write this, continue this. I is equal to this as it is, minus 1/4 e to the power x cos 4x as it is. Then what we do is plus 1/4 is also same. See this part, okay, this part is basically whatever we got over here just now. So I need to write 1/4 multiplied. Instead of this, I'm gonna do this. We did once integration by parts, and inside that again we got the same situation, that is product of two terms integrating. So again we did integration by parts, and now we are getting over here. I'll remove this 1/4 and 1/4 entirely common outside. I'll just leave it, it's fine. It's 1/4 e to the power x sine 4x minus 1/4. Now what I'm going to do is, I know this e to the power 4x I assume to be I, right? Instead of writing over here the entire thing, I'll just write it as I. 1/4 of I. Now let's try and simplify, because see, now this integral went. Otherwise, if we write this integral again, it's going to be looping. It's going to go forever. So that's why we consider this to be I. When you do 2 times, you're going to get back to the question, and this is I now. Now we will be doing simple simplifications. How? We're just going to multiply and solve it up. So I is equal to, over here, negative 1/4 e power x cosine 4x plus, I'll just multiply this 1/4 inside. So it'll be 1 by 4 times 4 is 16 e to the power x sine 4x minus 1 by 16 I. Why? Because this will be multiplied here and here. Now I can take this, whatever is over here, to the other side and add it up to I. Why? Because I and I are same, right? And if I take it to the other side, what's gonna happen? Let me take a stable color back. I plus 1 by 16i. This is what we are gonna get. And then over here, right side, it's the same thing. Right side, what's remaining? This entire thing, we have to just write it again. It'll be negative 1/4 e power x cosine 4x plus 1 by 16 e to the power x sine 4x. We are nearly there. Now what is I plus 1/16 of I? You can do it in the calculator, but otherwise you can just multiply. It'll be 17 by 16, isn't it? So you're adding 1/16 to a whole. So it'll be 17 by 16 I. Sorry for that. 17 by 16 I. That is equal to this entire thing. Now over here, what I'll do is, this entire thing should be written as it is. I'll just rearrange and write it over here. I hope that's okay. 1 plus, that much was, over here, 17 by 16. We are almost done, but we need I. What is the value of I, right? So I will take the 16 to the other side and 17 to the other side. So I will be equal to you have to multiply throughout by 16 and divide throughout by um, 17. So it's going to be, see, for the first term, these terms are going to remain the same. Only the first over here, the numbers, it'll be minus 16 divided by 17 times 4 e to the power x cos 4x plus, here again, it'll be 16 divided by 16 multiplied by 17. Why? Because this, when it goes to the other side, becomes in the denominator. The denominator goes to the numerator. And we have over here e to the power x sine 4x. And now we can simplify this. This is going to be 1 by 17. And what's this going to be? 1 times 4 times. It's going to be minus 4 by 17. So that is the answer. It is I equals negative 4 by 17. I'll just rearrange this and write I is equal to negative 4 by 17 e to the power x cosine 4x, and over here we will have 1 by 17. So that is the answer. I hope I have not missed any sign or not done any silly mistake. So this is the thing. Let's just look into the final answer. You can see here. Yes, it's absolutely correct. Okay, now I forgot to write plus c. Don't forget integration constant. It will be plus c. That is a simple thing. So this is the final answer. Negative 4 by 17 e to the power x cos 4x plus 1 by 17 e to the power x sine 4x plus c. Okay. So this is how you solve. You don't need to write C1, C2. You just write C1 constant, because it doesn't matter how many constants. It's just a constant. It's just a random number, right? So that's fine. So this is how we do it. Now, just over here are the detailed steps. So I have erased it and written it over here only. Anyways, you can just rewind the video and see each step properly if you want it again and again. Now we will do another problem. Now this is again similar problem. There's nothing much in this. See, just like what we did, it's going to be 2 times. So you please do it by yourself. Over here, the written thing is there. The only difference over here would be when you assume u is equal to e to the power 2x, right? What's going to happen? Du by dx is e to the power 2x multiplied with what? 2, chain rule. So du is basically 2 times e to the power 2x dx. That's the only thing. Anyway, see over here. Now over here, I think so it gets cancelled. But you will have 2 times e to the power 2x. That's the only difference. And then just like what we have done, you can follow it. You can rewind the video, what's that? Each step, very important. And that's how we solve. Now here we have got cos x 2x dx. This problem is similar to the previous one, but it's just that we have cos x, cos 2x. Now, which are you going to choose as u, which are going to choose as dv? Will it make any difference? Now, if you know this, if you take it as v, it's going to be cos 2x dx integrated, and you're going to get, sorry, this is dv. v will be 1 by 2 sine 2x. This is it. If you're going to take this as u, if you take this u cos 2x, it'll be du by dx, that is equal to cos 2x times 2. That's the only thing. It'll be half over here, it'll be times 2 over here. And if you solve it up anyway, doesn't matter. If you take this as cos 2x, the other one will be cos x only. Otherwise, it'll be, you will get the answer correctly. It'll be the same answer. What let's do is, let's see what they have assumed over here. See, they have assumed u to be cos x, dv as cos 2x. Generally, I would take u as cos 2x. Now, how about we solve this? I will take other way around and let's compare the final answer then. The reason I would take this as u is very simple, because differentiation is easier. That's what I personally feel. Integration, you need to remember the rules and everything, and becomes a fraction, half, right? Rather than that, if I have 2 to multiply, it's easier. Now let's do this. I will consider this to be I, because I know this also might recur. U is equal to cos 2x. So du will be, it'll be minus sine 2x times 2. This is du by dx. And let's see what is du. Du will be minus 2 times sine 2x. What about dv? We will take the remaining part, that is cos x dx. Integrate both the sides. It's going to be v is equal to, it'll be positive sine x, that's a plus c. We write the constant at the end. So this is all that we need, u, du and v. Let's put it in the formula. I equals integral, sorry, not integral, u and v. So I'll write the formula over here, uv minus integral v du. So what is u? It is cos 2x. And what is v over here? It is sine x. So this part is done. Minus integral of sine x. V is sine x, simple. But what is du? It is minus 2 times sine 2x. And I forgot to write this dx over here. It should be dx times dx. Now then, let me rearrange this. It'll be, I'll write sine x first. Whichever has 2, I'll write it as second. Or you can write, cos first, sine second. It's fine, whichever thing you want to follow. I just write sine x, cos 2x. Now, what is this sine? When you bring it out, it's going to be plus. And what is the constant? It is 2. So integral, now 2 is out. What remains is sine x sine 2x dx. Now it's very similar to this, but it is not that. It is similar, but over here we have cosine, over here it is sine function. So we need to do u substitution again. Now again what I'll do is I will assume u to be, now this time it is sine 2x. U is equal to sine 2x. What is du by dx? So du by dx will be directly cos 2x times 2, and du is equal to 2 cos 2x dx. Now what is dv? dv will be the remaining thing, that is only sine x dx. Now integrate both the sides. It will be sine x dx. When you integrate it, you're going to get here v. And here it is. Now integration of sine, the answer is cos, so it will be minus cos x plus c. We'll write it later. Now let's put this back into this formula. Now left side, this all remains the same. Let me just change the color now. It'll be I equals sine x cos 2x plus, here this is constant again, but this entire thing we write it by this formula now. What happens? It is u is sine 2x. What is v? V is minus cos x minus integral of, what is v again? It is minus cos x times this du. It is 2 cos 2x dx. That's it. Now then, let's close the bracket and let's try to simplify. I is equal to, now this given question is I is equal to sine x cos 2x plus, here now it's not going to be plus. Why? Because this minus is multiplied. I just multiplied outside now itself. It's going to be minus over here, minus 2, I'll write cos x first, sine 2x, and what happens over here? Minus and minus will become plus, and 2 I'll remove it outside, integral cos x cos 2x dx. Okay. Oh, one thing I have I shouldn't have multiplied this 2 inside. I will, because this 2 is multiplied throughout this bracket, so I've done a mistake over there. So I'll just write this plus 2 itself over here, and this one, this sign, I'll write it over here. I hope that is clear. Why? Because if I'm multiplying 2, I have to multiply here and over here. It's for both the terms, right? This is one term, this is one more term. It's going to be 2 over here, and this is going to be 4. So let me multiply that in the next step itself, because there are big brackets. Let me write it properly. So brackets means If I'm multiplying this 2, it should be distributed throughout whenever there's plus or minus. So now let's simplify further. It will be sine x cos 2x plus. Now here, I'll multiply to this term first. It's going to be minus 2 cos x sine 2x. And let me just show this 2 over here and over here as well, right? So that is going to be plus 4. Now what is this exactly? Integral of cos x cos 2x dx. It's I. Over here we have. So for this entire thing, I'll write it as I. So this is what happens. And now I will take this 4i to the other side. Or since this is greater, I can leave that over here and move this to the other sides. But let me keep I on the left side itself. So I'll just take this over here. It'll be minus 4i plus I is equal to sine x cos 2x minus 2 cos x sine over here it is sine 2x. Okay, this is sine 2x. That's it. Now what happens here? It's minus 3i. Why? Because minus 4 plus 1 is minus 3i. That is equal to the same thing again. You have to write it again over here. Cos 2x minus 2 cos x sine 2x. See, it's a little bit tricky because if you miss one step here, then everything gets wrong, right? So be careful when you're doing the exam. Just after doing it, just check it again. And if your answer is like very weird, go back, see where you have done some error and get back to it. Now what you do is we can divide throughout by minus 3 because you can rearrange these terms and make this positive, but directly divide everything by negative 3. What happens is this divided by minus 3, this entire thing by minus 3, this by minus 3. So here you will remain only with I, and this minus and minus becomes plus. So I'll write this first. It'll be 2/3 cos x sine 2x. Now what about over here? It'll be minus 1/3 sine x cos 2x. Or you can just leave it like this as well. This is the answer. Just I've rearranged it. So that is supposed to be the answer. Now let's just look into the answer what we get over here because they have assumed u and dx to be something else. Let's look here. Yes, this is the same answer we got. You can see here it's 2/3 cos x sine 2x minus 1/3. They have written cos 2x first and then sine x. Now I forgot again, plus c. Please don't do that mistake. I've done it 2 times now. Please remember there is always plus c, okay? The constant of integration. And the last problem in this topic, it is natural logarithm squared dx. How do we do this? It's similar to ln x. We have done that before. So here you need to assume u to be ln x, but since it's squared, you need to take the entire thing. You can't do anything over here. So this entire thing is squared. And du by dx is what? The power rule first. It becomes 2 natural logarithm x into what is the derivation of ln x? So 1 by x. So du would be 2 times ln x divided by x into dx. Okay, this is the term. And then what is dv? I'll just write it over here. dv is just the remaining part. It's dx. So integrate on both the sides. You should get v is equal to x. That's it. And now let us use the formula. Integral of u dv will be equal to uv minus v integral of v du. So let's substitute. Natural logarithm x the whole square times what is v? V is x minus integral of x times what is du? It is 2 times natural logarithm x by x dx. Here the x and x cancels. So let's rearrange it and write x ln x the whole square. And we have over here the integration of, I'll take the 2 outside, constant term outside, ln x dx. Now, what happens is this side it's nearly done, no problem at all. But here we got integration of ln x dx. Now, we have already solved it in the example problem, so I will directly write the formula for here. Now, if you memorize this formula, I believe you can write that directly in exam. Because, because I remember long back when we used to solve problems, if we knew the formula by heart for integral of natural logarithm x, we used to always remember it's x ln x minus x plus c. This was directly we used to write, so it's fine. But you should do all these steps, and then over here I'm going to write it as x natural logarithm x minus x plus c. I'll just write this plus c at the end, because constant, even if you multiply 2c, it's going to be c itself. It's unknown constant, right? Can be any number. So that's the thing. Now here it's going to be ln x the whole square minus, multiply this 2 throughout, minus 2x ln x plus 2x plus c. So this must be the final answer. Let's quickly check the answer. Here each steps are there, and you can see it's x ln x the whole square minus 2x ln x plus 2x here. That's how we solve it. So that's how we solve these problems, integration by parts. I hope you have found this helpful. It's been a long video. Please do practice these problems thoroughly, be well versed with it, and then when you look at the problem, you'll understand which to assume as dv, and you can solve them easily. We move to the last question in the writing part, question number 20. It is about trigonometric substitution. And they have clearly mentioned it's x equals a sine y. This y is just a variable, it can be anything. You can take it as sine theta as well, that's fine. But they have told you this formula, so we can just focus on this formula only. Now we need to recall a few of the trigonometric formulas. The Pythagorean identity, that is sine square x plus cos square x equals 1. This is important. And then we can derive the other ones. And there is secant square minus tan square x equals 1. And then you can easily derive the others. Similarly, over here, we have cosecant square x minus cot square x. Remember only the first part here, first one. You can rearrange them. This is by just moving cos square to the other side or sine square to the other side. You will get the other two. Because they have already mentioned it's x equal a sine y, just stick to one, that is more than enough. And double angle identities are not required for this particular topic, but in general, if you remember them, in case for simplification, if you need, we can use them up. And there are trigonometric integration identities. Obviously, we are dealing with, trigonometric substitution. So you need to know the basic trigonometric integration formulas. And they are simple. Now over here, if you can see a pattern. Whenever there is c cosine over here, see cotangent, c involved, co something, cosecant or cotangent, cosine over here, they will have negative signs. Okay, whereas it doesn't matter you're integrating sine or cos. The answer, if it is c, it will have negative. So please remember this, because over here you're integrating sine, you're getting minus cos. Don't think, okay, for secant you should have minus. No. For cosecant you should have minus, because what's the answer? If the answer is having co, then it's a minus sign. Over here, natural logarithm cos x, right? So you have a minus sign. Now we will look into the formulas. These are the actual formulas, but you're so lucky that you have to deal only with one. That is, your problems will be in terms of a squared, that is a constant, minus x squared. Now that will be the substitution which you'll be using is x equals a sine theta. This can be y as well, don't worry. Now here, since there is square root and square, the intervals are mentioned, but you don't need to worry about that much. This formula is important. 1 minus sine square equals cos square theta. Now let's solve this up. Here, first thing, you need to see how the form is given. Now, since they have given only one type of problem, no matter what, your question must be in terms of a squared minus x squared. So now you have other terms, that's fine. Now, how would you write this constant as a squared? You can write that as x squared root of 4 square root of 4 is 2, so you can write 2 square minus x squared. So this is how we get it. Now, you know a value is what? 2. So how can we write x now? We have been told we have to use this particular substitution. We can't go with anything else. We have to take a sine theta. That is the formula over here. Now you might be thinking, why we complicated so much? Why can't we directly solve it? I mean, some problems will be possible to solve with direct substitution if you strategically take the substitutions, Now, say, for example, this was x outside, then yes, you can try with, taking this term as something, and then yes. But now, otherwise, say this problem, it's not possible to solve other ways. This is the only way. So mathematicians had tried a lot of different methods, and then they came with, this a sine theta substitution and solving such cases. Now here, if x is a sine theta, what happens over here? A is 2 sine theta. So this is what we have to substitute. But we will substitute x fine, then the constants. But what about this dx? Now we don't have x anywhere. So we have to derive it. Dx would be dx with respect to theta, right? Because right side is theta. It'll be 2. What is the differentiation of sine? 2 is a constant. Differentiation of sine is cosine theta. That's it. Now let's take this theta to the other side because we want only dx. Dx is equal to 2 cos theta d theta. Now we have dx and we have x. Let's substitute it back. So we will have to evaluate 1 by 2 sine theta the whole square, that is this x square, square root 4 minus again 2 sine theta the whole square. What is dx? 2 cos theta d theta. This is it. Now, how can we go further? First of all, let's simplify how much we can. Say, multiply this power inside and what we can do, how much we can, let's simplify it. So what I'll do is this, instead of writing it outside this fraction, I'll write it in the numerator because it's up only, right? Instead of 1, I'll write 2 cos theta d theta divided by 2 multiplied by sine theta. So the square is for both the terms. 2 square is 4 and we will have sine square theta. And what about this? Here we will have 4 minus, again it will be 4 sine square theta. Now what happened to this 2? I squared it. 2 square is 4, sine square is theta. Now we don't take the whole square because this is not plus or minus, it is just 2 multiplied by sine theta. So when it's ab the whole square, that is a square b square. Okay. Now if it was a plus b or a minus b the whole square, then we have to use the identities like 2ab plus b square and so on. But for now, it's just multiplication. So just square both the terms and we get it. Next, what do we do? Here, this is done. I mean, we just simplified. Nothing is done. We are just rearranging it. See now, given question and this is equal. Why? Because we have assumed x to be so and so, dx we found out from this x, and we have just substituted. We have just manipulated the given question. That's all. Now let's try and solve something more, like if we can. Now over here, integral, let this 2 cos theta d theta be there. Over here, let's leave that. Okay, we can cancel this 2 and 4. We will do it in the next step. Sine square theta. Now here you can see there is 4 and 4 and there is a minus. If there is minus or plus, you can remove that 4 common out. Everything is inside the square root. When I remove that 4, what happens is over here 4 is gone, 1 minus this 4 is gone, only sine square theta is remaining. So look here, if I multiply this 4 inside, I'm going to get 4 times 1 is 4, 4 times sine square theta is 4 sine square theta. It's the same thing. I've done nothing wrong. Now here, if I have square root and 2 terms multiplied, I can split the square root. It's square root 4 and square root 1 minus sine square theta. So over here, wait, 2 times 1 and 2, right? So what we have is cos theta d theta divided by here sine square theta. And this Square root 4, if I bring this 4 outside, it's going to be 2. Why? Okay, I should have written 2 over here as well. This 2 is remaining 2 and another 2. Why? Because I've brought the square root 4 outside. It's 2 and then I have square root 1 minus sine square theta. Next, what I can see is 1 minus sine square theta. Now I know from Pythagorean trigonometric identity, it is cos square theta plus sine square theta equals 1. If I take the sine square to the other side, it's going to be 1 minus sine square theta, that is cos square theta. So integral cos theta d theta divided by 2 times 2. There was 2 over here. 1 by 2 by 4 is 1 by 2. That is in denominator 2. And 2 will be 4 sine square theta, and then what do we have? Square root, but 1 minus sine square theta is cos square theta. And now this square root and square can be cancelled off. So this is going to be cos theta d theta divided by 4 sine square theta into cos theta. Why? Because the square is gone. Now this cos theta cancels, and I'm just remaining with 1 by 4 sine square theta d theta. Now, do you know what is this formula? How can we solve this? But before that, I'll just clear this out over here. Now we have 1 by sine square theta, and there is no integral formula for 1 by sine square. But you know what is 1 by sine square? It is cosecant, right? So I will take the constant out, 1 by 4th, I'll remove it out, integral. Instead of 1 by sine square, I'm going to write cosecant square theta d theta. Now does anyone recall any formula here? It's 1/4 integral of cosecant square is minus cot theta. So this is the answer. If we solve this given question, we are supposed to get this answer. But you might be thinking, okay, here we had x. Now there is nowhere x to be found out. What if you have to substitute some value of x or anything? We know that x is 2 sine theta, isn't it? So what is sine theta exactly? Sine theta equals x divided by 2. I just divide both the sides by 2. You get this over here. Now what information does this give? Now don't take theta. If you substitute theta, it'll be in terms of sine inverse. It's more complicated. Though it's correct, it's better to do this. You know the unit circle method. Over here, imagine this is theta. We know sine is always opposite by hypotenuse. So opposite side for theta over here is x. Hypotenuse is 2. So what is this adjacent? Adjacent would be basically using Pythagoras theorem formula. This is 90, right? This is adjacent. That will be square root 2 square minus x squared. How did I do this? Because we know, imagine this is unknown. I'll write it as a adjacent adj. So adj square plus the other two sides, this x square will be equal to what? 2 square. Why? Because it is the hypotenuse. That's the Pythagoras theorem. A square plus b square equals c square. Now I need what? Adjacent square. So I will take this x square to the other side. It will be adjacent only I need. It's squared, right? Will be equal to 2 square minus x square. Now take the square root on both the sides. You're going to get adjacent side equals 2 square minus x square. So another easy way to write is, if any of this side is unknown, that side will be equal to square root of the hypotenuse square minus any one known side. So that is 4 minus x squared. So this is the adjacent, that's cos, right? Adjacent. Now from this we can find many things. What we can find cosine, we can find tangent, we can find sine. Sine is already known, but the other two now can be found out because we know all opposite, adjacent, and hypotenuse. Now what is given over here? We have cot theta, that is cotangent. So let us find the tangent over here. Tangent, you can directly find cotangent, but you know tangent formula is something that you will all generally remember. It is opposite by adjacent. Opposite by adjacent, right? So no hypotenuse over here. So opposite side is over here x divided by square root of 4 minus x squared. So now this is tan. But what is cotangent? It's the inverse of this. Cotangent cot theta equals square root of 4 minus x squared by x. So now technically over here, whatever the answer we got, right? We know what is the cotangent value, isn't it? Now this was like this. I'll just rearrange this and write the answer is supposed to be minus 1/4 cotangent theta. We can leave that as the answer. It's a writing, so generally you will get a lot of marks, but if you're aiming for the full top marks, it's better to convert this and now write over here minus 1/4 square root 4 plus, it's minus, sorry, it's minus x squared divided by x. Now when we write this up, it will be minus square root 4 minus x squared by 4x. This is the final answer. I hope this is clear. So the integral of this would be over here. This is the final answer. So that's what we get. And let's check the answer. It was negative 1/4 cot theta, but in terms of x, this is root of 4 minus x squared by 4x and so on. So you can see over here, we take 2 sine theta and we derive it. And what did we get when we derived? We got it as 2 cos theta. It's very important. It's positive cos. Don't get confused with integration. And then d theta over here, and we substituted everything back. See, the question became like this. And then what we do is we try simplifying, rearranging. Finally, we got this answer, negative 1/4 cot theta plus c. Okay, now I forgot to write one important thing, guys. Over here, the final answer should have plus c. Why? Because we did integration. So we don't need to write anywhere before. When we finally use this integration over here, see, this would have plus c. I just remembered that. Please don't make that same mistake in your exam. Remember to write plus c. But I just realized that they have stopped it over there. But it's good to convert it back to x, okay? Because I think over here they're all converted back to x. Yes, you can see over here they're converted back to x. Now let us solve one more problem. I won't do this one because this is just like what we did just a while ago. Let me do another different one. Okay, almost all are the same ones. Okay, let me do this anyways. But over here there is x cube on the top. So let's try this out. So looking at this, you know it is only one formula for you. So it resembles a squared minus x squared, the square root of that. So we will rearrange this. 9 can be written as 3 squared minus x squared. And what do? We need to assume x is a sine theta, right? So what is a? 3 sine theta. This is done. And now what is derivation? Dx will be, I'll directly write it. It will be 3 cos theta and d theta. It will be over here. I just written it directly. Now let's substitute everything back. It will be integral of x squared will be a. I'll not write a. I'll write 3 cube. And we have sine cube theta. I did not write whole cube. I just split the cubes directly. And over here we have 9 minus, what is over here? It is again 9, because it's 3 square is 9 sine square theta. And what is dx? Dx is 3 cos theta d theta. Now let's rearrange and write how much we can. Over here it will be 9 3s are 27. 27 times 3 is 81. So I'll write it all together. Okay, integral, I've multiplied all of them, it will be 81. And over here we have sine cube theta cos theta d theta in the numerator. What is there over here? We can remove this 9 common, and I'll remove it out of the square root, so it's going to be 3 outside over here, and we will remain with 1 minus sine square theta. This is again 27, back to 27, and this 3 cancels off. We will have sine cube, wait, I'll do the other things later, cos theta d theta divided by, what is up over here? This one will be cos square theta, square root of cos square theta, and then this will be cos theta itself. Why? Because square, right? It's gonna be cos. So I'll just cancel this entirely. The square root and square root cancels, you're remaining with cos theta. This is gone. This cancels off, and then what are we remaining with? It's only sine cube theta. But oh, I just remember this 27 I have not written out over here. So it's 27. That's the constant, so I can remove it out. Sine cube theta d theta. Is there any formula to solve sine cube theta, integral of sine cube theta? No. But there is a formula for sine cube theta. I'll write it out over here. So sine cube theta, that is equal to, there's no space over there, it's 3/4 of sine theta itself. Okay, it can be sine cube x, then it will be sine x, 3/4 sine x. You should subtract it with 1/4. It's like a, what I remember in my mind is this is a whole, right? 1, but 3/4 sine theta, 1/4 will be sine 3 theta. So this is the formula. So now I will just rearrange and write this out. It's just, this is what we had assumed. We do not need that anymore. We needed to put it back to x, but it's a simple thing to remember. Here, it is 27 integral. Instead of sine cube theta, I'll write 3/4 sine theta minus 1/4 sine 3 theta. Is that okay? And what do we have out? D theta. Now we can integrate this. Why? Because there is minus, so we can integrate this individually, isn't it? This is all together. Now this was a single term over here, but we used the formula of sine cube theta and got this. How would you solve this now? See, here you can take 4/4, 1/4, 1/4 outside. So I'll just take that. It'll make it easier, you know. So I will take 27 divided by 4, because this 4 is a constant altogether. I've taken from both and written over here. And integral, what is there? 3 sine theta. Now over here I can't remove 3 because 3 is not there in both. Sine 3 theta is not same as 3 sine theta, okay? So I'll write this minus integral of 1/4 is gone out, right? So I'll have only sine 3 theta. Now both should have d theta, because I'm splitting this and this. See, this in the bracket, right? Distributive property, integral and d theta for this term and for this term. Over here it'll be minus. And now what we can do is we can just solve them up. Here, first one is pretty simple. What is the formula? It will be over here 3 minus 3 cosine theta. Then plus c, we will write it together at the end because there are two terms. Okay, this is the first term. Straightforward, there's no problem over here. But this one, what happens is it will be 1 by 3 because it's in terms of sine a theta. What is the formula? It is 1 by a sine, sorry, it's cosine now, cosine a theta and minus sine. The formula for sine a theta. So we have sine 3 theta. So it will be 1 by 3 cosine 3 theta. And this minus is multiplied over here. So what happens is minus and minus becomes plus. Okay. This is the answer, plus c. Now I'll just multiply this inside. It's going to be, you know, you're just put in the calculator and solve it. But 27 3 times is 81. So 81 minus 81 by 4 cos theta plus, over here what happens is 3 1 times and 3 9 times. So it will be 9/4 cos 3 theta plus c. So this is your final answer. Now here we have everything in terms of theta. What if we want in terms of x? Then I hope you remember we just now did this. X is equal to what? 3 sine theta is what we had considered. So sine theta equals x by 3. See, now over here, generally, since you have 3 theta, you can find cos theta for this. But since there is 3 theta, it's safer to just find theta value. So generally, they just find theta is equal to sine inverse of x by 3. So over here, this would be, you can, 1 minute, let me just look into the final answer. So they have removed this out itself. They're not multiplied it inside, but we have multiplied it. It's fine. You can follow whichever, you know. This is also absolutely right. No problem at all. Or this is also absolutely right. Now I'll stick to what I've done over here. Cos into sine inverse of x by 3 plus 9/4 cos 3 times 3 theta, right? sine inverse of x by 3 plus c. So this is the final answer. Let us just look into the answer over here. It looks very weird, but over here they have see that 27 by 4 is outside. Then we have minus 3 cos. What is theta? Now you can just focus on see this part, Over here they have left it out over here. They have not multiplied it inside. That's fine. I've just multiplied it inside. Now what is theta? Is sine inverse x by 3. You can see. Same thing over here. Cos. Over here they have missed out. See, this is 3 theta. You just can't divide it. Don't think, okay, 3 and this cancels. No, there must be 3 times sine inverse. So please mind this error over here in this question. Everything is right, only the 3 is missing, okay, in the solution. Now this is correct. Over here, this one, absolutely right. They have forgotten this 3. Now theta would be sine inverse x by 3. So this, or over here only in this step, you can substitute what theta is. Over here, you can substitute theta in terms of x, and that's enough. So this is how we solve these problems. Please do practice each problem by yourself. The method is same, assuming x is equal to 3 sine theta. No matter which problem comes for the 20th question in writing, it's the same thing. So you don't have to worry. Directly assume that. And then it's like a puzzle. You start putting in pieces over here like Lego, substituting stuff, simplifying, and trying to get the final answer. That's the end of all the writing part. I hope this has been helpful. I wish you all the best, guys. Please do practice more problems and write and study. Don't just watch it. When you're watching the video, please try practice writing. Before I finish off, I just want to thank each and every one of you who have subscribed to my channel, who have liked my videos, who watch my videos. It really means a lot. It's nearing 7,000 subscribers. It's nearly 7,000 now, 50 more to go. I really am amazed by the support and love I receive from all the students. Thank you so much. And I will try my best to do all the explanation videos as soon as possible. Please do stay tuned.